All right, get ready to have your minds blown because today we're going deep, like way deep into the Earth's history.
Deeper than your average deep dive.
Oh yeah, this is going to be epic. We're talking about the Serpent Mound disturbance
Okay.
over in Ohio.
A place where the Earth's history is, well, it's kind of flipped on its head, literally.
And that's putting it mildly. We're
Yeah.
talking forces so powerful. I mean, just imagine a giant asteroid slamming into Earth, billions of tons of space rock just vaporizing on impact.
Or maybe a volcanic eruption so huge.
Like Mount Vesuvius times 1,000.
Yeah, something like that. Both of those scenarios are actually on the table here.
And that's what we're going to dive into today.
Exactly. We've got some incredible research from the Ohio Division of Geological Survey.
Real in-depth stuff, scientific papers, maps, the whole 9 yards.
Yeah, so we're going to be piecing together clues alongside geologists.
Uncovering the secrets of this crazy event.
Exactly.
So what exactly are we looking at here? The research mentions something about 3 main zones, right?
Yeah, right. Picture this. A giant bullseye, right? In the center, you've got the central uplift.
Okay, so the ground's been pushed upward.
Exactly, violently pushed upward. Then you've got the transition zone.
So things are still messed up, but not as bad.
Right. And then finally, you've got the ring graben.
The ring what now?
It's this outer ring of downdropped rock, basically a giant circular trench.
Okay, so it's like a giant target just painted on the Earth's surface.
Yeah, it's pretty wild.
Now, I'm no geologist, but that sounds like an impact to me.
It's definitely a strong possibility, especially when you look at some of the details.
Like what?
Well, for instance, they found these things called shatter cones in one of the core samples.
Shattered cones, what are those?
They're these cone-shaped fractures in the rock.
Cracks.
Yeah, but they only form under extreme pressure.
Like the kind of pressure you'd get from a massive asteroid impact.
Exactly. It's one of the key pieces of evidence pointing towards an impact.
So these tiny little cracks are telling us about an event that happened millions of years ago.
That's the power of geology. Rocks hold so many secrets just waiting to be unlocked.
It's like a time capsule.
Yeah, it's amazing, right? And there's more. The seismic data.
Seismic data, what's that?
It's like basically sound waves used to map out what's underground.
Okay, gotcha.
So the seismic data shows this bowl-shaped area of disturbance that extends incredibly deep.
Deep, like how deep?
Miles deep, through layers of sedimentary rock and even into the ancient Precambrian basement rocks.
Whoa, okay, so we're not just talking about a surface level scratch here. This thing goes down, down, down.
It really gives you a sense of the power involved, right?
Yeah, for sure. You know, kind of like the power of, never mind. Back to the science.
Okay. So this depth, it's actually one of the reasons some scientists are leaning towards the volcanic eruption theory.
Oh, how so?
Well, they argue that only a massive eruption originating deep within the Earth's mantle could create this level of deep-seated disturbance.
Okay, I see. So we've got Team Asteroid and Team Volcano battling it out.
It's a geological cage match. But wait, there's another twist.
Goo town.
The research mentions something called an iridium anomaly.
Iridium, what's that?
It's the super rare element on Earth's surface, but it's much more common in asteroids.
So finding it here means...
It could be a smoking gun for an impact event.
So Team Asteroid wins.
Not so fast. There are theories suggesting certain volcanic eruptions could also bring iridium up from deeper within the Earth.
This is so frustrating. Like trying to choose between 2 equally amazing desserts, you know? So, speaking of which, any plans this weekend? Maybe we could grab some ice cream.
Let's stay focused on the Serpent Mound for now, okay? There's still so much to uncover.
Fine. But we're not done talking about this weekend, are we?
Okay. Now, where were we? Yes, the iridium anomaly. So, before we got sidetracked, we were talking about that iridium anomaly.
Right. The one that could mean it was an asteroid or a volcano. It's just so confusing.
Yeah, it really is. And it gets even more complicated, believe me. The research actually goes into the underlying geology of the whole area.
Like what kind of rocks are there?
Well, yeah, but more specifically, it talks about the presence of ancient fault lines, you know?
Faults, like cracks in the earth.
Yeah, exactly. Geologists call them Precambrian faults.
Okay, but what do those have to do with the Serpent Mound thing?
Well, think of it like this. These faults are like weak spots in the Earth's foundation. Okay.
Right.
So imagine a giant asteroid crashing right into an area that's already got all these cracks.
Oh, I see. So it's like hitting a weak spot and the whole area just crumbles.
Exactly. The impact could have reactivated those faults, making the whole disturbance way bigger.
Wow, that makes sense.
Yeah.
But wait, how does the volcano theory fit into all of this?
Well, in a similar way, actually, if you've got tons of magma building up underground, These faults could be like pathways for it to rise up to the surface.
Oh, leading to a massive eruption.
Exactly. So yeah, those faults could have really set the stage for either scenario.
Kind of like how your laugh, never mind. We should focus on the science stuff.
Right, focus. And these faults, they might have even affected how sediments were deposited in the area way before the Serpent Mound event even happened.
So we need to understand what the area looked like way back then to really understand what happened later.
Exactly. It's all connected.
Man, this is making my head spin a little, all this talk about asteroids and volcanoes. What if something like that happened today? I mean, I'd be terrified.
Well, as I said before, these kinds of events, they are rare.
But not impossible, right?
True, but don't worry too much. We're getting a lot better at detecting potential threats from space. And scientists are constantly learning more about volcanoes.
Oh, that makes me feel a little better.
Yeah.
You're really good at explaining this stuff, You should come to this lecture with me this weekend.
A lecture?
Yeah, it's about the history of meteor impacts.
Interesting.
Yeah. And maybe we could grab coffee afterwards or something.
I appreciate the offer, but I'm actually kind of busy this weekend.
Oh, okay. Maybe another time then.
Yeah, maybe another time. Anyway, back to the Serpent Mound. There's another interesting thing we should talk about, tectonic inversion.
Tectonic what? Is this going to make my head explode?
No, it's not that complicated. Basically, it's this idea that, areas that used to be pulled apart can later get squeezed back together.
Like a geological accordion.
Yeah, exactly. And that squeezing, that can cause even more deformation.
So we've got asteroids, volcanoes, ancient faults, and now tectonic plates all playing tug-of-war with this area.
It's a lot, I know, but that's what makes it so cool. Each piece of evidence is like a clue.
Leading us closer to the truth, like detectives.
Exactly. It's like we're solving a mystery that happened millions of years ago.
Speaking of mysteries, I'm starting to think you're not being totally honest with me about this weekend.
What do you mean?
I mean, are you seeing someone else or something? Is that why you're busy?
Look, I just said I'm busy. Okay. Can we just focus on the topic at hand? Please.
Okay, fine. But we're not done talking about this weekend. Now, the research mentioned something about alternative theories for what happened at Serpent Mound. Tell me more about that.
Okay, well, one theory suggests that maybe it wasn't just one big event.
What? You mean like multiple asteroids?
Yeah.
Or multiple eruptions?
Maybe, yeah. It could have been a series of smaller impacts or volcanic episodes over a really long time.
Multiple events instead of just one big bang.
Yeah.
That is a cool twist.
Right. And there's some evidence that might support this, like the breccia layers they found in the core samples. They've got a mix of different rock types.
So that could mean there were multiple episodes of smashing and mixing.
Exactly. And the seismic data also shows a really complex network of faults at different depths, which could also point to repeated tectonic activity.
Multiple events, huh? Like that time I went on 3 dates in one day.
Oh.
Yeah, and each one was more disastrous than the last. Never mind. Bad example. But seriously, is there any way to know for sure how many events there might have been?
Unfortunately, no, not really. The evidence can be interpreted in different ways, and that's part of what makes geology so fascinating, but also frustrating sometimes.
So it's still a mystery.
Yeah, a mystery with millions of pieces, and we're still finding new ones all the time.
Well, I'm ready for more pieces.
Yeah.
What else you got for me?
Let's talk about the age of this disturbance. You ready for some seriously deep time?
Hit me with it. I'm feeling adventurous.
Okay, so initially scientists thought this whole thing happened sometime between the early Mississippian and the Illinoisan glacial period.
The what and the what now?
The early Mississippian, that's around 345 million years ago, and the Illinoisan glacial period, about 125,000 years ago.
Okay, so basically they were saying it happened sometime between, the invention of the wheel and last Tuesday.
Pretty much. Yeah, not very specific.
Yeah, not helpful at all.
But luckily, further research has narrowed it down a lot using something called paleomagnetic analysis.
Paleo what now? Wait, don't tell me it has something to do with magnets, right?
You got it. It's this technique where they analyze how magnetic minerals are aligned in rocks.
And that tells us?
It tells us about the Earth's magnetic field at the time those rocks formed, like tiny compasses frozen in time.
That's so cool.
I know, right? And based on this analysis, they now think the Serpent Mound event happened sometime in the late Paleozoic era, maybe during the Pennsylvanian or Permian periods.
Okay, so we're talking 300 to 250 million years ago.
Yeah, around there.
Still crazy old, but at least it's more specific.
Exactly. And it brings up some interesting possibilities, like if it happened during the Permian period.
When all those crazy extinctions happen.
Yeah, exactly. It makes you wonder if the Serpent Mound disturbance could have actually played a role in all that.
Whoa, that's insane. So this thing in Ohio could be connected to, like, global scale changes. That's mind-blowing.
It really is. It shows you how everything is connected, even across millions of years.
You know, you're really good at making this stuff so interesting. It's almost like I'm right there with you, exploring all these ancient landscapes. Maybe we could, do some exploring together sometime in real life.
Look, I already said I'm busy. I really need to go now.
Wait, what? But we're not finished talking about.
Okay, later.
But hello. Okay, so last time we were talking about how this crazy event in Ohio, the Serpent Mound disturbance, could be linked to, like, massive global changes. It's crazy to think about.
Yeah, it really is. It shows you how everything's connected.
And how even stuff that happened millions of years ago can still affect us today.
Exactly. And speaking of which, there's this one thing about the Serpent Mound disturbance that we haven't really talked about yet.
What's that?
The research mentions this weird structural depression right beneath the central uplift.
Oh, yeah, we talked about that, like a giant bowl within a bowl, right?
Right, and that's actually not something you typically see in impact craters.
So how do scientists explain it?
Well, one theory is that it formed because of the impact itself. Like, imagine an asteroid slamming into the Earth with that much force.
The shockwaves must have been insane.
Exactly. So much so that it could have caused the rock layers underneath to just collapse inward.
So basically, the impact punched a hole in the Earth's crust, and then everything around it just caved in.
Pretty much, yeah.
That's wild. You're kind of like that impact yourself, strong and just irresistible. Okay, I'll stop. I'm sorry.
Can we please just focus on the science here?
Fine. But hey, if this impact was so powerful, why don't we see more of it today? I mean, should there be a giant crater or something?
Well, you got to remember that the Earth is constantly changing, Erosion and other geological processes can really change things over millions of years.
So the original crater could have been way bigger, and it's just been worn down over time.
Exactly. What we see today might just be a tiny remnant of what was once there.
That's kind of sad, in a way.
I think it's more awe-inspiring, It reminds us of how much time has passed and the incredible forces that have shaped our planet.
Yeah, I guess you're right. It's like looking at the ruins of some ancient city. You can only imagine what it must have been like back then.
Exactly. And it's like geologists are like archaeologists. They're constantly piecing together the story of the Earth's past.
You're really good at explaining this stuff. Like, I can almost see it all happening.
Thanks. I try.
Hey, maybe we could, explore some of these places together sometime. For real.
Look, I told you, I'm busy. I gotta go now.
Wait, hold on. What am I doing wrong here? Why won't you just...
This isn't the time or place. Goodbye.
Folks, it seems I've hit a bit of a roadblock in my personal life. But that's science for you, always full of surprises. And speaking of surprises, who knows what other mysteries are hidden beneath our feet, just waiting to be uncovered. Until next time, keep exploring, keep questioning, and keep diving deep.